Alright, operation of equipment. Number 6 SL brake equipment for diesel electric yard switching locomotive instruction pamphlet number 504615 June 1950. Alright, operation of equipment. It should be clearly understandable that the diagrams of the equipment plates 1 through 9 are not intended to show actual construction operated devices compromising the equipment, but are distorted and drawn so to make the connections operation more easily understood. Automatic brake rigging. Automatic brake operation, releasing and running position function, charging and releasing the brakes can be accomplished by either both release or running position. Brake valve running position only. The full release with nullifiers available to handle automatic brake valve when desired to nullify the release position. Use running position for the release for the train brakes instead of the release position is found with the have the advantage of avoiding stuck brakes many times on account of liability overcharging along the locomotive. Cars are the nearest locomotive when the release is used. The length of the time that the automatic brake valve release position, it must be carefully determined, or is the brakes likely to reapply on a light overcharge when brake valve handle is returned to running position. Release and charge position plate 1 with the main reservoir charged and handle 55 of the automatic brake valve handle release position with the air flows through the dirt collector main reservoir pipe into the brake valve and distributing valve in turn of the brake valve through port 7 of the main reservoir flows from passage 7 in chamber A above the rotary valve 36. Hence, through the rotary valve port not shown in the diagrammatic, ports 1A and 1 on the brake pipe charging in the entire system as the same time port J for the rotary valve register for the equalizing reservoir, port C for the valve C permitting air to main reservoir pressure for the entering chamber D above the equalizing piston 41 of the equalizing reservoir. As the equalizing piston chamber P in the 6K are distributing valve is connected with the brake pipe. With the brake pipe air flows through the V valve groove V past the piston 26 into the chamber. The equalizing slide valve 31 through the port of the pressure chamber until the pressure on both sides of the pistons in 26 are equal. If the brake handle of the rear valve remain in loose position, the brake system would charge to the main reservoir pressure. Avoid the handle of 55 must be moved with the running and holding position to prevent the engine man from forgetting the small port discharge feed valve air atmosphere in the release. The cavity of the rotary valve 36 connects with the port 20 with a warning port on WP. In the seat allows the small quantity of the air to escape with the exhaust cavity EX, which makes the sufficient noise to attract the engine man's attention with the position to the handle. Plate 1 running. The automatic independent handle over the brake valve with the running position. Plate 1 cavity R with the automatic rotary valve connects with the port 20 with the port in the valve seat affording large direct passage of the feed valve with the brake valve pipe. So the later will charge with the entire system rapidly with the feed valve can supply the air but cannot attain the pressure above that which from the feed valve is adjusted. From the port also flow with the cavity J with the port C2 to the chamber D above the equalizing piston 41. Chamber D is connected through port 5 of the pipe and pipe connections as shown to the equalizing reservoir and gauge. The purpose of the equalizing piston and reservoir will be described later in surface application. The port 1A mentioned above the branch V with the willies to the underside of the equalizing piston through over the brake valve with the handle with the running position with the V valve maintains practically constant pressure of 70 pounds to 110 pounds as the case may be, and the brake pipe on the underside of the equalizing piston with the same pressure with the equalizing reservoir chamber D with the opposite side of the piston. The end of the equalizing piston stem is called the equalizing discharge valve when and which and when open allow the air of the brake pipe to flow through port M and passing the equalizing discharge valve through the port of the surface exhaust fitting with the atmosphere at the exhaust. This valve is held with the seat at all times and when the air pressure in pounds per square inch is the same under the upper side of the piston because the pressure of the air above the piston acts the entire air over the piston while below it acts on the area which is less than that above the amount of the area of the piston stems. This makes the total pressure on the top of the piston slightly higher than below, thus holding the piston down, equalizing discharge valve on the seat. Air entering the brake pipe pedestal connection 1 flow through the branch pipe BP connection of the distributing valve, thence the chamber P for the equalizing portion Brake pipe air flows from the feed groove valve V for the piston 26 into the chamber above the equalizing slide valve 31 through the port to the O to the pressure of the chamber that under the pressure. Both sides of the piston are equal. The application chamber is connected with exhaust and the brake valve through the port W, cavity K, equalizing slide valve, port 1, distributing valve, release pipe connection 4, and the brake valve pedestal through port 4, past independent brake valve exhaust 134, port 19, cavity Q, and exhaust port. Are the brake cylinder pipe is connected with the distributing valve of the exhaust and the atmosphere port C, D, and E. Surface application plate 2. The system being charged is described as say about 70 pounds with a brake pipe pressure, automatic brake valve handle 55 is move the surface position of the port E with called the preliminary exhaust of the port leading to chamber D. Equalizing reservoirs open the permit for the air to escape from above the equalizing piston through the port E with the rotary valve seat with a cavity Q and with the rotary valve exhaust port with the atmosphere that's once reduced with the pressure of the air over the top of the equalizing piston 41 below the brake pipe under the piston and the higher pressure move of the piston upward raising and attach the equalizing discharge valve with the sheet with allowing air from the brake pipe flow through open M passing valve past the valve through the passage N with the surface exhaust fitting into the atmosphere. It will now be clear that the purpose of the equalizing reservoir with the add volume chamber D with above the equalizing piston without the equalizing reservoir. This volume is so small that the brake pan over the surface position is pressure would drop zero almost instantly, but it would consequently be very difficult to make moderate brake pipe reduction and practically impossible to obtain the exact amount of the reduction desired in any given case. When the pressure in chamber D is reduced to the desired amount with the handle over the lap position, stopping any of the further reduction in the chamber, whether the flow of the air over the brake pipe ceases at once or continues for a period of time after the handle is placed in the lap position depends on whether the train is a long or a short one. The short train with the total volume of the air brake pressure is not very great, so the escape of the surface exhaust nearly as fast as the air in chamber D, equalizing reservoir is flowing out through the preliminary exhaust port E. Thus, the pressure below the equalizing piston is falling about the same rate as above. In such a case, as soon as the pressure chamber D ceases to fall, the brake pipe pressure below the equalizing piston becomes slightly less than that above the piston, with a high pressure move of the piston downward, seating the equalizing discharge valve, preventing further flow of the air through the brake pipe. On a long train, however, the total volume of the air brake pipe is larger. That takes longer sufficient air to escape through the surface exhaust fitting to reduce the pressure and pressure below the equalizing piston. Therefore, the fall is a slower rate than above it. In such a case, air continues to escape from the brake pipe after the handle has been placed in the lap position for a period of time, depending on the length of the train, until the brake pipe pressure has been reduced slightly below that of chamber D. When the equalizing piston is moved downward, the surface exhaust opening closed explained, it will be seen that the equalizing piston and equalizing piston and valve automatically measure amount of the air which must be discharged from the brake pipe in order to obtain the desired reduction and govern the rate of discharge according to the length of the time to the degree which imposes the flow of the air from the brake pipe to the atmosphere directly controlled with the brake valve handle. Equalizing piston by closing slowly with the pressure falls prevents the surge of air in the head of the brake pipe in which it opens or closes quickly and might cause some of the head brakes to release. At the brake pipe, it is connected with the chamber P with the distribution and reduction brake pipe. Pressure can describe will lower the pressure over the brake pipe side with the equalizing piston 26 below, but the opposite side of the piston result of the piston moving toward the right. First moving the piston close with the V groove of the V. At the same time, move the graduating valve 28 until it uncovers the upper end of the port Z. Equalizing slide valve 31. As the piston continues within movement, the shoulder the end of the stem. Engage the equalizing slide valve, which then also is moved to the right until the piston strikes the graduating stem 44 on the cylinder cap, preventing further movement to form. Port Z is equalizing slide valve, then registers port H in the seat with the cavity. Equalizing slide valve connects the ports H and W in the seat, and equalizing slide valve chamber is always communication with the pressure chamber. Air can now flow the later both application cylinder G and application chamber. If the pressure builds up in the chamber G to the left, the application piston 10 over the number 6KR distributing valve of the piston 10 attached. Exhaust slide valve with a move to the right, cutting over the exhaust ports D and E. Slide valve chamber B. As the piston continues its move at the end of the stem contacts application pilot valve 71, move the later from its seat. allowing main reservoir air chamber to airflow with the slide valve chamber B, then hence through the passage C to the brake cylinder pipe. With the pilot valve unseated, the pressure reduced in the chamber all A1 faster than it can be restored with the main reservoir pressure choke A2. Therefore, the application valve 68 approaches the balanced condition in which the unseated and slightly excess of the application cylinder pressure on the left application piston chamber G over the brake cylinder pressure over the right over the piston. With the application valve 68 unseated, the main reservoir air chamber as is freeze flow over the brake cylinder through the large capacity opening. This provides adequate rate for the brake cylinder buildup of the large brake cylinder volume, very light differential across the application piston. Alright, during the movement just described in C2, and it's just described in cavity T, and the graduating valve 28 connects to the ports R and S of the co-equalizing slide valve of the same ports R and S are brought to register in ports H2 and 1 in the seat, and establish communication between the application cylinder G and the safety valve. Surface lap position, plate 3. After the described pipe of the production has been made, the automatic brake valve is returned with the surface to lap position, plate 3. The already has been described in this portion of the brake valve. The brakes are applied throughout with the train, with the further brake pipe production and release is made. When the brake pipe production is not sufficient to cover the full surface application with the condition of the described above, with the reference to the distributing valve continuing with the total pressure of the pressure chamber is reduced enough to the below of the brake pipe chamber P with the cover of the piston 26 with the graduating valve 28 to the left until the top of the shoulder of the piston stem and then striking with the right hand end of the equalizing slide valve 31. The piston known as the service lap. In this position, the graduating valve 28 port C so that no more air can flow from the pressure chamber to the application cylinder and application chamber. It has closed port S and cutting off the communication with the safety valve so that any possible leak and later cannot reduce the application of the cylinder pressure, thus similarly affecting the pressure of the brake cylinder. And number 6KR distributing valve with the flow of the main reservoir application valve 68 with the brake cylinder continued until the pressure of right application piston 10 slightly exceeded the application cylinder pressure at the left of the piston. The piston will move to the left. The springs then close action valve 68 and pilot valve 71, preventing further flow of the air to the brake cylinder. A greater differential pressure on the application piston 10 with the required for the move of the piston exhaust slide valve then to the move of the piston alone. Therefore, piston stops it comes into contact with the slide valve because of the exhaust slide valve of 16 still blanks exhaust port exhaust in lap position. The pressure of both sides of the pistons are balanced. Under this condition, if a brake cylinder pressure should be released by leakage, the position will move to the right and open the pilot valve application far enough to restore the brake cylinder pressure with the approximately with the application cylinder with the brake piston will again be moved in lap position constant with the brake cylinder pressure maintaining feature. Alright, release and recharge plate 1. To relieve the brakes of the brake handle, brake application automatic brake valve handle is moved to the running position. In this position, air with the feed valve flow through the port 20 with the cavity air with the rotary valve with the ports 1A and 1. Then directly with the brake pipe, and then at the same time from the air from the passages also flow with the cavity J with the port C with the chamber T above the equalizing piston 41 through port 5 with the equalizing reservoir. Feed valve air is emitted with the brake pipe through port 1 with the brake valve flow with the distributing valve chamber M1P with increase of the pressure for the air in above the pressure chamber to causing equalizing piston 26 to move to the left, carrying it equalizing slide valve 31 graduating valve 28 into the position shown. Feed groove V now will being open permits the pressure of the pressure chamber to be restored until it's equal with to that of the pressure that is through there before described. Distributing valve release pipe at the beginning of the atmosphere through ports 4, exhaust valve 134, independent brake valve port 19, cavity Q and the rotary valve automatic portion, the exhaust port exhaust added to the atmosphere, cavity K exhaust slide valve 31 and the 6KR distributing valve connects ports 4, 1, W and H in the valve C with the application cylinder G chamber will escape through distributing valve release pipe of the atmosphere. At this pressure reduced, the brake cylinder pressure will move the application piston 10 with the left up until the exhaust valve 16 uncover the exhaust port D and E, allowing brake cylinder air to escape, or in case of the graduated relief to reduce like amount of the reduction in application of the cylinder pressure. Holding during automatic release plate 4. To hold locomotive brake applied with the unit of the train brakes being released with the brake pipe recharged with the feed valve pressure handle with the automatic portion of the brake valve is removed with the hold position. All of the port registers into the running position with the exemption port 19, which leave the distributing valve release pipe application cylinder is closed with the air pressure, which may be in the application cylinder for the previous or for the application is then bolted there with the preventing of the air from releasing from the locomotive brake cylinder. Therefore, only difference between running and holding position is the former locomotive of the brake is relieved, the later is held and applied. Emergency plate 5. When it is desired of the short possible stop, the brake valve handle 55 is laid for the emergency position, and this opened the brake pipe directly with the atmosphere, large port 1A and cavity Y with the exhaust port covered with emergency rate with the reduction brake pipe pressure. Cavity also connects to the port C and H to the exhaust port, allowing the air in chamber D, the equalizing reservoir, to escape to the atmosphere. The reduction of the brake pipe pressure thus causes it takes place that so much more rapidly during the surface application of the brakes that the air pressure of the pressure chamber, the distributing valve, move with the equalizing pistons quickly in extreme position at the right ceiling against the gasket compressing equalizing piston graduating spring 46. Movement of equalizing piston on the right cover the equalizing slide valve 31 to uncover port H from the seat, making a direct opening with the pressure chamber of the application cylinder, the only then quickly becoming energized, and to ensure equalizing piston being held with the emergency position, main reservoir air is permitted to flow through a restricted opening by the way of the port A and cavity J and the rotary valve of the automatic portion of the brake valve, port 2 with the C with the application cylinder pipe into the application cylinder G, with the application cylinder volume being small but connected to that the pressure chamber is 70 pounds. Pressure, low pressure services equalizes about 65 pounds. The application cylinder G is now connected with the safety valve port H2 with the seat with the cavity Q and port R with the equalizing slide valve, port 1 and seat cavity Q, and on port R with the equalizing slide valve that are connected by a small port, size of which proportion to the size of the maintaining port automatic brake valve with that pressure floating with the main reservoir. Application cylinder will escape safety valve with the rate with which limited brake cylinder pressure the sum of the will be considerably higher than obtaining full service of the brake application, in which will less be the main reservoir pressure. As a result, rapid direct equalization pressure chamber application cylinder pressure application piston 10 of the number 6KR distributing valve is moved promptly with the right when the obtained with the application valve 68 fully when produced. The fast buildup of the brake cylinder pressure is described under automatic service. Movable parts of the distributing valve remain in the position shown below. The brake cylinder pressure slightly exceeded the application cylinder pressure when the application piston 10 and the application valve moved back to the lap. The release after the emergency brought is to about the same manipulation automatic brake valve with the following surface application is explained under release and charge. If the emergency application is made with the emergency brake valve with a burst of the hose parting with the train, the operation will be as above. The described handle of the automatic portion brake valve that should be independently moved to the lap position to prevent loss of the main reservoir pressure. Your independent brake operation. As mentioned before, the function application portion of the distributing valve with the control of the flow of the air from the locomotive brakes in with the movement of the application piston 10, which actuates the exhaust application valve that depends on the variety of the air pressure of the application cylinder, which the pressure may be indirectly controlled by automatic portion of the brake valve through the movement of the equalizing piston slide valve with the graduating valve directly independent portion of the brake valve. Therefore, by considering the use of the independent portion of the brake valve, the locomotive brake manipulation of the equalizing portion of the distributing valve may be disregarded altogether with the application piston cover considered as being moved by the air of the application chamber, controlled directly by the independent portion of the brake valve. The operation of the equipment independent brake valves running plate 1. This position with the handle of the independent portion of the brake valve which has carried at all times over the independent brake is not in use. The exhaust valve 134 with the independent brake valve is open, connects to the exhaust, connects to port 19 and 4, establishes communication between the distributing valve with the release pipe and between the application cylinder G with the distributing valve with the exhaust over the automatic portion of the brake valve with the locomotive brake cylinder pipe is open to the atmosphere for that through port C, D, and E to the exhaust of the distributing valve. Application first stage plate 6. To obtain the application locomotive brake with the independent brake valve handle 55 with the move of the right with the farther movement of the handle The greater amount of the application half of the handle is moved to the right with the camshaft at 76, the move of the dog 144, the push pinner 139, attached lever the ends of the R position on the inlet valve 122, exhaust valve 134. Spring pressure plus air pressure acting held on inlet valve 122 is heavier than the spring 148 acting to hold exhaust valve 134 open. Therefore, in first move of the handle, come to the move of the balance lever the cover of the exhaust valve 134 to close, cutting off of the brake valve with the exhaust. With the further movement of the brake valve handle with the right causes the additional movement of the balancing lever on Falcon closed exhaust valve 134 on the inlet valve 122 that permits the main reservoir airflow from passage 7 flow in the brake valve chamber F, the supplying application air with the passage check valve setting 7B through passage 2 to the application cylinder pipe. At the same time, application air also flows from chamber F to passage 4 distributing valve release pipe. The distributing valve air application cylinder with the pipe 2 flow with the passage 2, application cylinder 3, 2 with the cavity K with the port W with the application chamber with the air from the distributing valve leave the pipe through passage 4 and I cavity 4 and 1. Cavity K equalizing slide valve with the port W with the application chamber, the 2 channel with the flow with the provide with the fast build with the application cylinder pressure quickly moves application piston 10 to the right, opening application valve with the 68 fully with the permanence of the main reservoir airflow to the brake cylinder pressure. Build up pressure there and same rate application pressure is being increased. This flow will continue until the pressure in the brake cylinder exceeds the application cylinder when the application piston move to the final application stage. When the independent brake valve handle 55 is moved out of the running application position with the exhaust valve pawl 94 with the shaft 76 contacts exhaust valve plunger lifts exhaust valve 97A from the seat of the passage 19 with the self-lapping exhaust 134 is provided with the opening atmosphere regardless of automatic brake valve handle position. This ensures the proper operation of the self-lapping portion of the brake valve. Or your independent application final stage, plate 7, the pressure builds up the brake valve chamber. If it acts upon with the spring load of the piston 127, the performs the exhaust valve C with the moved piston 127, the exhaust valve 134, compressing spring 148. The exhaust valve thus remaining closed with the exhaust valve end of the floating lever 138, move the exhaust valve with the piston so that lever fulcrum handle cam application valve end of the valve lever moves away from the inlet valve after the valve 122 is closed and spring 1 by 123. In this manner, self-lapping unit operates quickly, accurately building up the pressure, distributing valve, release position, application cylinder pressure pipe considered to the position and brake valve handle. In the application portion of the distributing valve application, piston 10 move to the left is shown that the independent application final stage. Application valve 68 and pilot valve 71 are closed in spring 75 and 76 respectively, preventing further flow of the air to the brake cylinder. Slide valve 16 lap ports E and D, preventing loss of brake cylinder air of the brakes over the held applied until the further application of the release is made. Independent release after the independent application to plate 1. To release the locomotive brake handle with the independent brake valve to remove the running position, move to the running position. The brake valve handle is moved to the toward the running position. The handle can moves away from the balancer lever the pusher pin 139. Self-lapping unit lever 138 with the fulcrums on the closed inlet valve 122 with the spring 148 moves the cause exhaust valve 134 from its seat. That permits the distributing valve of the release pipe of the air with the flow of the atmosphere pipe past exhaust valve 134 passage 19 cavity Q. The exhaust port of the brake valve exhaust. The brake valve handles is moved with the only port with the toe of the running distributing valve release pipe air and brake valve chamber F. The acting on the piston type of the exhaust valve seat 127 will only reduce the pressure of the piston. Spring 148 will move the seat 127 with contact. Exhaust valve 134 prevent further flow of the air to the distributing valve release pipe. Brake valve handle with the running position handle is moved away from the balancing lever exhaust valve. Spring with the 148 holds valve 134 open to vent all air pressure of the distributing valve release pipe. Thus, distributing valve release pipe pressure is decreased in small graduations of entirety as desired. Or venting distributing valve with the release of the pipe air permits air from the flow of the application cylinder G with the distributing valve through the ports H1 2 cavity K distributing valve slide valve 31 1 4 through the distributing valve of the release pipe 4 with the previously described with the greater brake cylinder pressure of the other face. Move the application of the release position is shown with an imposition of the air of the brake cylinder pipe flows to the atmosphere through ports C, D, and E with the distributing valve exhaust. Independent release, automatic brake applied, plate 8. The brakes have been applied throughout the train by means of the automatic brake valve described in the strip of the application described with the release of the locomotive brake. The independent brake valve handle running position is depressed with the handle 55 of the depressed move with the actuating plunger, 82 of the action plunger, attach plunger collar down with the contact. He presses quick release valve with the open operating arm, 90 of the move of the plunger, 93 of the right of the movement. Unsee quick release with the valve, 97 with the air pressure, distributing valve application cylinder G with the flow with the passage H1 with the 2, application cylinder pipe passage 2 with 2A with the brake valve heat pass unsee the quick release valve, 97 through the independent brake valve exhaust, opening of the chamber at the atmosphere, brake cylinder air in chamber B, move to the application piston 10 with the lap position, release position, and permitting air with the brake cylinder pipe with the below with the port C with the chamber B with the hence of the exhaust, atmosphere port D and E with release of the locomotive brake with none of the operation chamber the condition either with the pressure of the chamber of the brake pipe. Consequently, equalizing pistons does not move until the release is made with the automatic brake valve. Alright, if graduated release is desired, quick release valve of the 97 must be closed before all application cylinder pressure is lawful. To do this, the handle 55 is returned to the upper position, permitting the spring 83 to the move of the plunger, 82 upward to allow away from the operating arm, 90 anchor pin spring 92, move the 90 away from the plunger, 93 spring 98, quickly go over the release valve 97. In this way, the independent release valve may be graduated as really desired. Independent application after independent release, automatic brake as applied plate 9. If it is desired to reapply the locomotive brakes after the release of the train brakes, remain applied with the handle of the independent brake valve is moved to the application position. Locomotive brakes are reapplied with the previously described except for the application from the air with the independent brake valve chamber out through the passage floor with the distributing valve release pipe is cut off, and the application shown with the G with the slide valve 31 distributing valve with the after with the automatic application air flow for the independent brake valve control chamber F with the distributing valve with the application cylinder G with the application chamber of the pass application check cell valve 97 and B passes through the application cylinder pipe with the passage of the 2 H1 the distributing valve with the on branch for passage 2 lead with the application chamber the wave with the cavity N with the passage W. Independent application after the automatic application plate 9. If desired, increase the locomotive braking pressure, the automatic brake application less than full service. The independent brake valve handle 55 is moved to the right application position. This allows the exhaust valve 134 open the inlet valve 122, permitting the main reservoir air from passage 7 to flow with the control chamber after the unseat with the application check valve 97B. Application air through can through for the passage 2 with the application cylinder for the pipe with the distributing valve application chamber. Application cylinder G with the operator with the application piston 10 and increase the locomotive brake cylinder air pressure the same manner as the previously described in application first stage. Alright, K86 speed pedestal brake valve standard valve operation. Standard valve will be located on the side of the brake valve diagrammatically on the plate 1, provide standing of the locomotive wheels finding forward and reverse operation. Reverse operation standing provided with the moving of the standard valve handle 187 the extreme left position shown with a view of the plate 1 main reservoir air from chamber B connected through A port rotary valve 179 and port 11 the reverse standing pipe. At the same time main reservoir air flows the choked warning port exhaust opening with the sound of the warning along as the handle is standing position. Standing is forward operation provided with the moving of the standard valve handle with the extreme right position plate 1 in the position. Main reservoir air connected through the port rotary valve 179 the port 113 forward ending pipe. Main reservoir air flows through the choked warning port with the rotary valve exhaust opening with the sound warning along. Handle remains in standing position. Neutral position plate 1 midway between forward and reverse. Main reservoir air is cut off with both standing pipe with the rotary valve. Standing pipes 11 and 13 are connected with the exhaust port through rotary valve 179. Your bell ringer valve operation. To operate the bell ringer valve with the lower valve handle 187A with the move of the left valve with the neutral plate 1 the position main reservoir air chamber C connected through port rotary valve 179A with the port 10 with the bell ringer pipe with the handle 187A is moved with the neutral plate wart 10. Bell ringer pipe is disconnected with the main reservoir supply with the connected with the rotary valve to the exhaust port stopping the bell ringing. Alright, equipment with the independent brake control of the locomotive then doubling heading surface. The equipment is the same as they already described except for the number 6 DKR distributing valve with a substitute with the number 6 KR 3-position brake pipe cutout is substituted with a 2-position brake pipe cutout cock on the brake valve with addition with the brake pipe with the main reservoir pipe, third pipe with the equalizing pipe that runs through the length of the locomotive See plates 11 and 12 for the typical diagrammatic pipe diagram of the equipment. Number 6 DKR distributing valve figure 25 is the same as the number 6KR, except for the filling piece 106 is inserted between the valve of the reservoir portion, which is the bolted transfer valve portion 308 with the dead engine fixture 278. Transfer valve show the relay double heading of the operation distributing valve of the first control locomotive onto that of the second locomotive. Thus provides independent brake valve control on both locomotives. The dead engine fixture performs a function over the cutout cock combine strain check the valve previously described and shown in figure 24. Your brake pipe cutout cock brake valve control with the usual pipe connection with the brake valve, also main reservoir pipe connection, the transfer valve piston chamber. Equalizing pipe serves as a connection between the distributing valve on locomotive, the double heading strip of which they provide for the control of the independent brake for both locomotives by connecting brake cylinder pressure developed on the first or controlling locomotive, the application cylinder pipe connection, distributing valve on the second locomotive. A brake pipe vent valve is used to ensure the transmission of quick action originating in either locomotive or to the train, and vice versa when operating road service. Alright, transfer valve figure 25, section BB consists of the piston 304 slide valve 203 attached with the filling piece, which all pipe connections are made with except for the brake pipe, brake cylinder pipe. Slide valve chamber is connected with the main reservoir air pressure, where the piston chamber is connected with the main reservoir pressure or atmosphere depending upon the piston over the brake valve with the brake pipe cutout cock. Your transfer valve diagrammatic view plate 11 has been port connections as follows. Brake valve cutout cock 7A, main reservoir supply pipe MR, brake cylinder pipe BC, equalizing pipe EP, the application cylinder equalizing slide valve C4B, application cylinder pipe 4A, piston 304 slide valve 303 are in forward position piston chamber. G opens the atmosphere figure 26. Application cylinder pipe is open through the slide valve 303 with the connections between the brake valve and the distributing valve are the same. With the chamber number 6KR, with the only difference being in the transfer slide valve 303 connected with the brake cylinder pipe to equalizing pipe. With the piston slide valve forward position of the main reservoir pressure and piston chamber G, figure 27, the application cylinder is cut out from the brake valve connected with the equalizing pipe of the EP with the operation distributing valve of the controlling locomotive will be relayed with the second locomotive through equalizing pipe that is distributing valve of the second locomotive will function duplicate with the brake cylinder pressure developed on the control locomotive. 3-position cutout cock brake valve plate 11 is driven with the usual brake pipe cutout cock. In addition to the other function, lead locomotive is operated with a single unit or as number 1 double heading of the cutout cock will be in position number 1 opening with the brake pipe port 1. Brake valve port 1A connected with the transfer valve piston chamber 9 to the atmosphere. On locomotive operating in the second unit, the double heading of the cutout cock will be in position number 2, closing the brake pipe port 1 to the brake valve port 1A, connected with the transfer valve piston chamber port 9 to the main reservoir port 15. When locomotives are hauled with the dead end, the train handle with the brake valve shall be in running position with the cock under the brake valve handle. So brake valve should be in position number 3, position number 1, except for the brake pipe, the port 1 is understood over the course of the distributing valve with the dead engine cock should be open. When locomotive U, the pusher for the cutout cock should be in play with the same position, dead engine operation, but dead engine cock should remain closed. Operation equipment number 6 DKR distributing valve. Operation of the equipment C diagrammatic view of the plate 11 C they already described except as follows. Independent application with a handle with the independent brake valve application position main reservoir instead flowing direction application cylinder G with the distributing valve now flows with the filling piece 287 through the passages 4K 4A cavity B with the transfer valve slides valve 303 then through the passage 4B and H1 the application cylinder with the brake cylinder pressure flow with the equalizing pressure through the brake cylinder in cavity C with the slide valve 303 with the double the heading surface of the brake cylinder air pressure equalizing pipe flow with the cavity B with the slide valve 303 transfer valve on the second locomotive figure 27 then force B 4B with the application cylinder which cover the application portion of the distributing valve with the function the same manner with that of the operating locomotive. Alright, independent relief. The running position independent brake valve plate 11 the air with the application cylinder J with the distributing valve and the tip of the passing directly with the passage 1 into the release pipe of the gnome that flows through passage 1A with the H1 filling piece with the ends from the release pipe of the brake cylinder valve with exhaust. As brake pipe cylinder pressure is reduced, the equalizing pipe pressure thereby reduces through transfer valve of the cutoff of the release of the brake pipe. Second, moving the locomotive of the application cylinder with the distributing valve being connected to the equalizing pipe through transfer valve. Multiple unit operation. When the two locomotives are coupled together, the brake pipe with the main reservoir pipe with the equalizing pipe, however, they must be coupled up to the two locomotives. They are cocks open. Where there are two more locomotives in the train, where the instructions are already given, them remain unchained. The leading locomotive, the locomotive from the brakes are being operated is concerned. Second locomotive on the operating multiple unit brake valve position with the cutout cock is moved to the position number 2, closing the brake pipe connection, brake valve connection with the transfer valve piston chain with the main reservoir pressure with the hand with the automatic brake valve to the lap position, independent brake valve is held into running. After the remove of both the brake valve handles, the brake over the second locomotive is operated with the first locomotive the same as the first locomotive. The type KM vent valve, figure 28, provided the means for the ensuring propagation of quick action with the train when the brake pipe is vented. Make an emergency application of valve. Figure 29 consists of the upper housing 2, which is bolted to the bracket 29, lowercase 3, which is bolted on the bottom housing 2 with the support slips pushing 5, in which moves piston 9, lowercase t, with the upper housing by gasket 13, piston shank guide extension lower and of the bushing 5 is formed in the seal of the gasket 11, the underside of the piston 9, with the pressure differential across the piston becomes great enough. Drill pour through the piston stem of this piston between the gasket 11 and the piston ring, provide the stabilizing passage. Flow through the passage leakage pass with the ring are limited with the gasket 11, which seals on its seat. Stabilizing passage drill port with the burners bushing furnishing the direct by the accurately restricted communication across piston 9. 3 unsetting pins firmly secure with the piston project upward with the drill passage of the end housing 2. Shoulder 2 plates engaged valve of 24 and 21 later sheath with the bushing pressure on the large exhaust quarter. And the body former sheath with a small sheath formed on the upper side of the valve assembly 21. Spring 20 guided with the bushing enclosed with the cap 4 with the energy of the bolt valve as they have their seat gasket 19 seal with the cap of the housing. As the piston moves upward, the unseating pin with the first lift valve with the 24 off the seat, with then valve 21 off its seat, exposing very large exhaust port, strain 27 that prevents entrance of large particles of foreign material level the entrance of the drill with the passage unseating pin with a high enough to loose the water like the chamber A will flow back into the pipe before it can get it to the operating parts. Piston stem of the drill with the receiver of the felt packaging on 37 of the saturated with light oil breathing of the small port and the stem monitor the chain with the pressure of chamber C supplied with the film and the lubricant for a stem tip with the bushing over the length of a period of time. Your brake pipe entering of the KM vent valve with the figure 30 with the flow through the strainer 27 the chamber A with the round with the discharge valve with above with the piston 9 and later is moved the time until the end of the stem. Gauge the spring cup 7 of stands the time of the rate of the brake pipe pressure developed is high on the locomotive. Brake valve handle in running position. Spring 8 will compress until the gasket 11 is sealed. On seat, the airflow with the stabilizing port with the A and B. In the chamber C with the oven the position changing with the brake pipe pressure low enough for the rate to afford adequate protection again with the overcharge valve 24-21 head tightly to their seat by combined load of the pipe pressure and spring 20. When the emergency rate of the brake pipe production occurs with the KM vent valve figure 31 with the capacity stabilized with the ports A and B is not sufficient to prevent high differential pressure that quickly develop with the cutoff of the piston 9 when the result of the piston move to the upward by ample force on seat valve 24 against the load of the tension spring 20 with the brake pipe pressure seat area. As soon as valve 24 is unseated with the brake pipe airflow through the open exhaust port greatly increase the rate of the brake pipe production, have the increase of the pressure differential curve of the piston creep, force necessary to cover the lower shoulders of the piston 99 to pick up the unseat with the large exhaust valve 21. Vent valve respond with comparatively light, differently required lift of the valve. Small diameter will almost instantly develops a very large venting capacity. Full opening of the two valves providing exhaust valve cavity equal to the internal diameter so of the standard 1 1/4 inch pipe. Piston 9 is limited with the travel to the top of the bus of the lower face of the housing, stabilizing port A and B, allowing chamber C to bleed down until spring 20 wave of the operating parts can move the exhaust valve with their seats closed with the outlet of the brake pipe permitting the reach over when desired. Alright, rules of operating. We're going to cut the tape there.